Hello everybody, welcome to this webinar. My name is Angelo Rizzo. I'm working in Posalux in Switzerland as a business area manager for electronics department. Today's subject is about making holes and cutting. So the topic addressed in this webinar can be summed up in one question. Does femto-laser micromachining match with guide plates and probes requirements? So I will provide answer to this question all along the next 20-25 minutes. So first of all, a quick overview on what we are talking about. We are in the world of laser micromachining. As you can see here, the focus is on micromachining for guide plates and vertical MEMS probes. Here you have an overview of the today's webinar. So I'm gonna to start with a quick introduction, then technical specification, the state of the art today. So what the industry is requiring to get a good and qualified product. I will spend time to explain about what is a femto-laser. Then I will discuss about increasing challenges and the work done by our application and R&D people. After this, I will go back to the initial question, so understand if really femto-laser is enough to cover the actual and future needs. And the question is, femto-laser, yes, but, and we'll see what are the other essential elements. Then I will finish with a quick conclusion and also make sure the initial question gets an appropriate answer. Ceramic guide plates processing by laser is well known in the industry. We also have seen a tendency to cut probes also by this process. Why femto-laser helps to achieve increasing challenges. And again, all along this webinar, we will understand if the femto-laser is enough to cover all technical requirements, actual requirements, and of course, also for the future. So now technical specification and the state of the arts for guide plates. So here we can see which are the main specifications for drilling and what must be achieved. So round, square, and rectangle holes, dimension down to 20 micron or less, corner radius, if possible, less than 3 micron for square holes or rectangular holes. Another spec which is also important is the orthogonality. We can see here in the picture where I show an example. So it should be always between 89 to 91 degrees. And surface quality, homogeneity of the whole and the whole quality, and of course here by homogeneity and quality of the surface we intend the rawness of the surface. Then to avoid any functional problem with the guide plates, there must be no damages and no micro cracks, and of course there could be also additional requirement. But here we talk about the most important, of course. So now technical specification about vertical and MEMS probes. So I announced at the beginning of this webinar that the tendency to machine this kind of probes by laser is increasing. So here we can see the most important specification. We start with size tolerances, which must be less than plus minus 1.5 micron, with a minimal width down to 15 micron. So here is an example, but we did it in our R&D. So this work to reduce the width of probes, where we actually achieved 15 micron, but of course it can be also less by femto-laser. A criteria to evaluate good result is to check the cross section, and you can also see here in the presentation the cross section of the probe, check the symmetry and check the taper. And so here we have a clear example of what pass and what fail in terms of geometry, in terms of cross-section evaluation. A sharp angle is also important to keep correctly the probe during the test. So this angle should be as small as possible, but generally should be less than 5 micron. Last but not least, the outlook after probes cutting is also a very important criteria or specification. The cutting uniformity and smoothness is a key point as well. So let's deep dive into the femto-laser technology. So what means femto-laser? A femto-laser is a laser which emits optical pulses with a duration well below 1 picosecond, and we are in the domain of femtoseconds. In this also belongs the category of ultra-fast laser or ultra-short pulse laser. In the picture here you can see a comparison between long pulse laser and an ultra-short pulse laser. For long pulse laser like microsecond or nanosecond laser, the main issue for long pulse laser is the material integrity. And you can see in the picture some ejected material, damaged surface, heat affected zone, melt zone, micro cracking, which are not present in the ultra short pulse laser process. You have no debris, no damaged surface, no melt zone. So we can say the femto-laser is like a cold ablation process. So the pulse duration of the laser is the key parameter to achieve a non-thermal process. The maximum pulse duration to avoid thermal effects is dependent on material. We can say generally a pulse duration less than 500 femtoseconds is okay for most of the materials. Here as well we can see the difference between ultra short pulse, which is less than 500 femtosecond, and a long pulse laser higher than 500 femtosecond. Three criteria: ablation rate, side effects, and heat affected zone. Ablation rate is okay for both long and ultra short pulse, but what is making the difference between long and ultra short is all what is related to side effects and heat affected zone. And here clearly we can see also through the pictures. So now that you have a better understanding of what a femto-laser is and also what are the specifications, let's talk about challenges. And here we put some points which we also worked out with our application team and which are also representing what are the tendency of the market and what we will need also in the future. So first, the increased number of holes per guide plate. So we did a test where we drilled more than 100,000 holes with reduced pitch. It means a wall thickness less than 8 micron, down to 8 micron. Second challenge, the productivity. When you have a lot of holes to be drilled, like example here, more than 100,000, the productivity is very important. We are talking about several days of production. So if we can reduce the time, production time, this is also very important because it will reduce the cost. The repeatability, reproducibility, and the consistency of the whole quality. So we run several days of production in a row. It means it is important to have the same quality of the hole from the beginning. So it means the first hole we drill and the last hole we drill must be the same. So we must achieve the same quality and consistency. So here we have a graph where we can see also all along a production the stability of the size of the holes, which here is about plus minus 1 micron. What is very important is also the high positioning accuracy. Here we have a process accuracy within plus minus 2 micron. So this is also the tendency to reduce or to make sure the positioning accuracy is stable and is also very small. Plus minus 2 micron is a challenge, but it is already running into production. Stability and reliability is also something that will be part of the challenges. We are running 24/7. So again, we can couple this one with the consistency we just talked before. The stability is very important. And then we also have to distinguish between R&D and mass production. So all what we are doing in R&D is very important. Then we apply for mass production, but it is not just apply what we did, it's also requiring some experience and some preparation and some adjustment to make R&D matching with mass production. To sum up, the FEMTO-LASER really helps to achieve challenges in terms of productivity and surface quality, but it doesn't cover all the challenges mentioned before or earlier. Some other components are essential to reach a higher level in application. And flexibility of the system, so we need drilling, routing, milling, and cutting. Several operations in the same process are also achieved using additional elements and not only FEMTO-LASER. FEMTO-LASER, yes, but a precession head is needed. In other words, optical 5-axis beam management system. So the technology as showed here, show the comparison between conventional laser drilling and the 5-axis drilling, where you can see the beam, the laser beam can be tilted, can be moved following some 5 optical axes, X, Y, Z, and incidence angles, and thanks to this, some geometries or specific geometries can be achieved. Here we can see 0 or negative taper, straight holes. So this is all managed by the 5-axis scanning head. FEMTO-LASER, yes, but a precession head is needed. The laser is moved helically with tilted laser beam. In the picture here, we can see from the left to the right side the complexity of the laser and beam management or beam management system, since a single pulse to a trepanning and go until the precession drilling, which is the most accurate in terms of optical axis movement, and you can achieve all kind of shapes, all kind of geometries. FEMTO-LASER, yes, but again, a precession head is needed. Here we can see 3 selectable geometries, and you have no damage of the whole shape. And somewhere all the spectrum of the holes and geometries we can achieve. Round holes, square holes, elliptical holes, step holes, and in terms of geometries, the straight, chamfer, tilt, negative and positive taper holes. FEMTO-LASER, yes, but a machine concept following fundamental design rules is needed. And here the most important point are all related to the statics, to the kinematics, dynamics and thermal behavior of the equipment, in his global behavior. When we talk about a machine concept following fundamental design rules, as I told before, the static behavior must take into account the efforts of the machine. We are using stiffness and isostatic structure on 3 feet, so it makes all the machine, all the equipment very stable, and the stiffness is there. We must make sure, according to this formula, the high natural frequency is the same than the stability of the system, and we have to take into account all acceleration and deceleration of the axis to make sure the stability is there. FEMTO-LASER, yes, but of course, again, a machine concept following fundamental design rules is needed. As we all know, the tolerances are getting tighter, and so the long runners means an equipment which is running for more than 24 hours, like I showed you before, the example of 100,000 holes. We need few days to complete production. So the long runners require long-term stability. It means, so we have, for example, 20 degrees, and all along the production, the stability must be guaranteed. And so, or in the environment of the machine, but also internally in the machine. This is very important to keep the stability all along the production. The choice of materials is also very important, and here the choice of the material for the structure of the machine. For example, we have the XY table in granite, which is the same material used for the structure. We have an active air conditioning system to keep all the temperature very stable during the production. We use to build some compensation matrix. For example, when we have a drilling room at 23 degrees Celsius and the machine is calibrated at 20 degrees, it must take into account this difference. But at the end, the target is to keep everything at ambient temperature without having high variation per day and during the production. All along the webinar, we have seen the benefit that FEMTO-LASER is bringing to the production, but we also learned that it's not the only key point to achieve the increasing challenges for the future. So we need a combination of different components, and here we show that using a 5-axis optical scanning head is also something very important. To build an equipment, to build a machine according to the state of the art is also a key point, and that all the three we have seen during this presentation. We also showed you the way where our application engineer developed some jobs, for example, to run more than 100,000 holes with a high stability of result. This is a combination of all the three elements we have seen before, but it is also a point related to know-how and experience we developed all along the last 5-6 years. This is the end of our webinar. I would say thank you very much for your attention. I hope you enjoyed it. Please also feel free to contact us anytime you need. And again, thank you very much, and see you soon.